All right, good morning, guys. So today we're going to get started on lesson 10.4. All right, so I already have some of the notes copied up on the board for you. I will post the notes, blank copy, and answer key on Google Classroom. We're going to break this into 2 days, okay? So we're just going to do half of it today. So let's go ahead and get started. The vocabulary, I didn't write it up. I'll just read it to you. So compound events. The union or intersection of two events, which we'll talk about union and intersection in just a minute, but compound events are the union or intersection of two events. Overlapping events, two events that have one or more outcomes in common. So we're going to have to take account for the overlapping events with some of our problems. And then disjoint or mutually exclusive events are two events that have no outcomes in common. Okay, so when we talk about the union of two events, so A and B, my Venn diagram, A is supposed to be event A and B event B. If we talk about the union of two events, we're talking about everything in event A and B. Okay, if we talk about the intersection of two events, we're talking about what they have in common, where they overlap. And if two events are disjoint or mutually exclusive, they have no outcomes in common. So you can see that my two circles for my Venn diagram do not overlap at all. Okay? So the probability of compound events, we find the probability by taking the probability of event A, taking the probability of event B, subtracting the probability of event A and B. So that's going to be the overlap, what was already accounted for. All right, now if there is no overlap, if the two events are mutually exclusive or disjoint, you don't have to subtract away the overlap. So for disjointed events, to find the probability of A or B, you just take the probability of A and add to it the probability of B. So we're first going to look at a disjointed event, okay, problem. Probability of disjoint events. So here it says a card is randomly selected from a standard deck of 52 cards, okay? What is the probability that it is a 10 or a face card, okay? So since 10s and face cards don't have anything in common, meaning there are no 10s in a deck of cards that's also a face card. There's not a face card that's also a 10, right? There are no outcomes that are the same. That's why it's mutually exclusive or disjointed. Okay, so if you want to visually think about this, in one circle, we'd have event A, which would be selecting a 10. So we have our 10 of hearts. We have our 10 of diamonds. We have our 10 of spades and clubs. And try to draw a club up here. Something like that, right? So those are our four 10s. Now, that's event A. It says event B would be selecting a face card. So for the face cards, we have 4 kings. We have 4 queens. We have 4 jacks. Okay? So, event A would be selecting a 10. Event B would be selecting a face card. There is nothing in common, which makes them disjointed events. Okay? So the probability of selecting a 10 or a face card is going to equal the probability of selecting a 10 plus the probability of selecting a face card. Okay? So how many 10s, what's the chance, what is the probability that you're going to select a 10 out of a deck of cards? Well, there are 4 10s out of 52 cards. So 4 out of 52. What's the probability that you're going to select a face card? Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 face cards out of 52. Now, if these were not mutually exclusive, if they were not disjointed events, that's where we'd have to come up here and subtract away the probability of A and B. Subtract away that overlap that was already accounted for. All right, so from here, you're just going to add to get 16 out of 52. Right, adding fractions, you add the numerators, keep the denominator the same. So that simplifies down to 4 over 13, which is approximately, as a decimal, 0.308, which as a percentage is 30.8%. Again, just give the answer according to the directions. If the directions ask for a percentage or a decimal or a fraction, just leave your answer in that form. Okay, so that's your first example for today. Let's look at another example. Try not to erase it all. All right, so for the second example today, we're going to look at finding probability of overlapping events. And some of the directions are the same, which is why I tried not to erase it. So a card is randomly selected from a standard deck of 52 cards is how this problem begins. And then it says, what is the probability that it is a face card or a spade? All right, so event A, selecting a face card. Event B, selecting a spade. Okay, so for your spades, okay, we have everything from an ace all the way up to a king, right? So we have an ace, we have 2, 3, 4, 5, 6, 7, 8, 9, 10. And then after 10, we have a jack, queen, and king of spades. I said it wrong, but that's it. A jack, king, and queen of spades. Now, I put the jack, queen, and jack, king, and queen in the middle because this other event is the face cards, right? And the face cards are your jack, king, and queen. So it's in both categories. It's both a spade and it's a face card. So over here, your other face cards, well, we have 3 more kings, right? We have, these are the spades, but we have hearts, jacks, and clubs. Hearts, diamond, and clubs, excuse me. Then we have 3 more jacks and 3 more queens. Okay? So, to find the probability that you select a face or a spade. Oh, well, I put space instead of spade. Sorry, guys. Just noticing that spelling error. Okay. So to find the probability of face or spade. You're still going to find the probability of selecting a face card plus the probability of selecting a spade. But then you have to subtract away the probability of finding this is this part here, of finding a face and a spade. Minus face and spade. Because they overlap, and those are going to be double counted if we don't subtract. So the probability of selecting a face, okay, well, how many faces are there out of the whole deck? There are 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 52. The probability of selecting a spade, well, how many spades are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 out of 52. But then you need to subtract away the ones that were double counted, the overlap, okay? So there were 3 out of 52 that were double counted. All right? So then when you add your numerators and subtract the 3, you're left with 22 out of 52. Okay, which is going to simplify down to 11 over 26, which is approximately 10.423, or approximately 42.3%. Okay, that would be the answer for that one. All right, let's just do two more problems on the next page of your notes. Let me erase. Okay, so on the next page of the notes, we're just going to do examples 1 and 2 today, and then we'll finish up the rest on the next lesson. All right, so for extra practice example 1, it says event A and event B are disjoint. So think about the Venn diagrams, just disjoint, mutually exclusive. They have no overlap. The probability of A is 2/3. The probability of B is 1/6. Find the probability of A or B. So we learned on the previous page that the probability of A or B for disjointed events is equal to the probability of A plus the probability of B. So you're simply going to take the 2/3 and the 1/6, add together, get common denominators, or of course you can use your calculator, but multiply both of these by 2. So it's going to be 4/6 plus 1/6 to get 5/6, which is approximately 0.83, which is approximately 83%. Most likely for this one, I'd want your answer in fraction form since the original problem was in fraction form, but there's all 3 forms of the answer. All right, and the last problem for today, it says probability of A is equal to 0.8, probability of B is equal to 0.05, and the probability of A or B is equal to 0.6. Find the probability of A and B. Okay, so this one, find the probability of A and B. They want to know what is the overlap. Okay, so we learned on the previous page that for overlapping events, probability of A and B is equal to the probability of A plus the probability of B minus the probability of A and B. So we're going to substitute in the values we know. We're given the probability of A is 0.8. The probability of B is 0.05. And the probability of A or B, this part here, is 0.6. So we're trying to find the probability of A and B. What is the overlap? Okay. So you're going to add, oh, I forgot my minus sign, sorry guys. You're going to add and move it to the other side. Okay. So you're going to have negative 0.25 is equal to negative probability of A and B. Divide both sides by that negative, and you're left with the probability of A and B is equal to 0.25, which we know is 1/4 or 25%, depending again on how the directions say you should leave your answer. Okay. All right, that should be enough for you guys to do the homework or problems that I'm going to assign for this evening. We'll come back tomorrow to finish up this lesson, and that'll be all for lesson 10.4. See ya.